The final speaker of this session is Marti Gilbert-Roca, and he will speak about enhancing light harvesting in organic solar cells by two-dimensional photonic structures.
Okay, thank you very much. Thank you for being here. Don't worry, I know we are all tired, so I'll be quick. I just want to present this work, enhancing light harvesting in organic solar cells by 2D photonic structures. What does this mean? Okay, yeah, the quality is much lower. I don't know why, this happened to everyone, I think. So what do we propose? In organic solar cells, we have, in general, a thickness compromise. We either make the active layer too thick so that it absorbs all the light, but then we lose completely the charge extraction, or we make it too thin so that we have better charge extraction, but we don't absorb so much light, so we don't have so much photocurrent. So what do we propose? Well, to solve this problem, we propose to increase light harvesting using photonic structures. This way we keep the active layer with the same thickness, and we increase the absorption. And as a bonus fact, if we made the actual active layer thinner, we could actually use less material per device. So, first thing first, we simulated things. What is this worth? Is this worth it? So this is the structure we simulated. We simulated an inverted configuration, and with the structure on the bottom of the active layer. And as you can see here, the structure has actually a much higher absorption on the active region below the band gap. So we actually decided to fabricate the devices. These are the two main fabrication configurations, inverted and conventional, with these materials you can see here. And they were deposited, they were all based in P3H TPC60BM because it's cheap and we can actually use a lot of it on the lab. And we use it via Dr. blading. And how do we actually structure the active layer? Well, we chose soft lithography because it's actually also cheap relatively and easy to do. And the way we did it was to deposit the active layer, apply a structured PDMS stamp on top, and then wait for a minute so that the solvent completely evaporates. And afterwards, we actually get a structured pattern, a structured active layer. As you can see here, really nice features can be transferred to the active layer. And well, here the lighting is not so good, but here you can see the active layer has different colors. These are structural colors. And you can see, well, here it's not, I cannot see it correctly, but it's blue, it's also green, it's also orange. So we actually have a rainbow of colors. So, first thing, optical characterization. We actually got the devices into the integrating sphere and we measured the absorption over all these spectra, the visible spectra. And as you can see here, the patterned devices show an increased absorption on both configurations, so that's promising. But okay, what we care about is electrical characteristics. So we made some JV curves, and actually not all of the devices show, they more or less show similar efficiencies. However, we see a trend towards higher photocurrents. So as you can see in this IV curve, we have higher, lower, but lower is higher, photocurrents. And the similar efficiency comes from a lower field factor, actually. So after that, we decided to make some light beam induced photocurrent mapping. And for that, we had a thickness gradient done also with the Dr. blade. It's thinner at the top, thicker at the bottom. And as you can see here, the patterns start to appear before the actual flat zones, and they show a significantly higher photocurrent, even at the thicker region. So, what can we conclude from this study? Well, the first thing, we actually we're able to transfer the photonic structures, which is already pretty impressive. The absorption was increased, and not only the absorption was increased, but the devices, the structure devices were functional and with similar efficiencies and a general increased photocurrent. And as a bonus fact, we actually get different colors on our solar cells. So we actually add color tuning to all this. So thank you very much for coming, and if you've got any questions, they're welcome.